All right, let's take a look at how we can use inverses to solve systems of equations. We've looked at graphing, elimination, and substitution as techniques, and those work great when you have two variables. But when you want to have more variables, matrices definitely are the way to go. So you're going to need to have downloaded these notes so that you can write on them, either a print copy or a digital copy. And you'll also need your calculator. So if you don't have those two things, pause the video a minute and get that. All right, let's take a look at this first question. We're starting with just two variables because I'm going to show you how it works with two, and then we will go to three variables and then four variables. So we're going to talk about a landscaping company. Landscaping companies right now are deemed essential businesses. We need to keep things growing, and so we'll look at how this works. A landscaping company placed two orders in the nursery. The first order was for 13 bushes and 4 trees. All right, that right away identifies our variables for us that we're talking about bushes and trees, two variables in this question, with a total of 487. The second order is for 6 bushes and 2 trees, a total of 232. The bills do not list the per item price, so we don't know how much one bush or tree costs, which is the question. So what I need you to do first is identify what your variables are. I usually stick with X and Y, but you can be creative in your variables if you would like to use a different letter. But I'm just going to say that X are my bushes and Y are my trees. And you should be pretty comfortable now setting up a system that represents this problem. This is kind of math you've been doing probably since middle school, and we just did 7-1B on it, so hopefully this is good for you. So we want 13 bushes and 4 trees as a combination with a total of 487, and 6 bushes with 2 trees for a total of 232. Now, of course, you could solve this with graphing, or elimination looks like a great way, but I am going to show you matrices for this one so that we can get that technique down for other problems. Now, a matrix is a grouping of values or variables that either is a square or a rectangle in combination. What we're going to do is we're going to create a matrix with organizing those coefficients. So 13, 4, 6, and 2. This is a square matrix. This has 2 rows and 2 columns, so this is called a 2 by 2 matrix. Now you want to grab your calculator, and I'm going to show you how to input this matrix into your calculator. Okay, when you turn your calculator on, clear it out, and the matrix key is right here, right above your inverse key, so I'm going to do second matrix. And we are going to give our matrices names. Now, my first matrix is matrix A. I want to go over to the edit option and select number 1. Now I need to say the size of this matrix, and we just decided it was a 2 by 2, so I'm going to hit 2, enter, and 2, enter, which will give me the chance to put the 4 numbers in the right positions. So 13 is the first, and then 4, followed by 6, enter, 2. So this is called a matrix A, and we'll be working with matrix A later on in the problem. All right, let's clear that out of the way here. Okay, now we want to set up our second matrix. And our second matrix is the variable matrix. And our variables are X and Y. We don't need to list them as a square matrix. We only need to list them as a rectangular matrix because they are repeated, and so I don't need to list them twice. And then on the other side of the equal sign will be our total matrix, which is 487 and 232. This is a rectangular matrix in the shape of 2 rows and 1 column. So this is called a 2 by 1. Now remember, we called this matrix A earlier, and this is going to be matrix B of the size 2 by 1. So let's get our calculator and enter that one in. Okay, I'm going to quit out of this screen, and I'm going to go to second matrix again, and this time I'm going to go down to matrix B, and I'm going to go over to edit, and I want to make this a 2 by 1 matrix. And so 487 was the first total, and 232 was the second. And so now we have matrix B entered in our calculator, and we'll come back to that in just a minute. All right, now the way matrix math works, let's look at what we have. We've got matrix A stored in our calculator times XY matrix equals matrix B. And now we want to get matrix XY alone. And so we have to do legal math to both sides. Now remember, it has to be legal. So we would want to get rid of matrix A somehow. Now some people would suggest subtracting matrix A. Well, that is not legal math. You can't subtract a matrix because there's no addition sign here. Other people might suggest dividing a matrix. Oh, just divide matrix A. But again, that is illegal too because there's no division in matrix math. The only thing we can do is something that is similar to division, which division is the same as multiplying by. Now normally we would say the reciprocal, but in this case we're going to say multiplying by the inverse. And so we're going to take matrix A and we are going to multiply it by matrix A inverse. Okay, inverse is the symbol for -1, and those two things will get multiplied together. Oops. So that would, and then matrix, the variable matrix x and y. Now whatever we do on one side, we have to do on the other side. So I have to multiply A inverse in front of matrix B. Now the in front of part is really important. The order matters. And so you have to multiply in front. What's going to happen on this side is those two legally cancel each other out. And then we will be left with matrix XY by itself, and we'll be left with a resulting matrix, and we'll have our calculator figure out what that is. All right, so remember I said that the order was important. So we need to call up matrix A first. So we're going to go to our second matrix, and I'm not going to go over to edit this time. Oh, what happened to my matrix B? Did I do that? I'm sorry. I am going to have to fix that. All right, I need my 2 by 2. That was 13, 4, 6, and 2. And I think when I entered my matrix in, I didn't do matrix B. Maybe you guys caught that I didn't do that correctly. All right, 2 by 1, 437, 232. Okay, now I've got matrix A and B both in there. Remember the order matters, so we just start with matrix A. So I'm going to put enter under the names. And then I'm going to use my inverse button, which is right underneath matrix. It's that little -1 symbol. And then I'm going to multiply, use the regular multiplication, by matrix B. So I'll go down and select matrix B. I'm going to hit enter. And there's our values. Now, the answer to a matrix should not be negative. Okay, I can't have the price of something be negative, so something was not right. So I'm going to go back and double check. I'm going to edit my matrix B. Oops. Edit my matrix B. And I noticed that I made it, again, you guys probably caught this while I was doing it. It should be 487, not 437. So I make mistakes too. I'm not going to re-record the video. Just have to live with my mistakes. And we're going to try this again. All right. Matrix. Oops. It's really hard to type sideways, by the way, while I'm doing this on the video. Matrix inverse multiplied by matrix number 2, which is matrix B. All right. Let's check moment of truth here. There we go. Okay. Now we've got 23 and 47. Those are going to represent the answers to the question that I was going for. All right, so 23 and 47. Remember that 23 now matches up to x and 47 matches up to Y. And so now we know the prices. So the bushes are $23 each, and the little trees are $47 each. Now you might be thinking, I could have gotten that answer way faster with elimination, and I totally agree. Elimination probably would have been the ideal way to do this particular question, but when you go to three variables, then you have to do elimination not just once, but once plus twice for a total of 3 times. If you go to 4 variables, you have to do elimination not once, not twice, not 3 times, but once plus twice plus 3 times for a total of 6 times. And so every time you add a variable, the steps of elimination, the steps of substitution, the impossibility of graphing in 4 dimensions or 3 dimensions, 4 dimensions specifically, that's why matrices are better when you have multiple variables. So let's take a look at that and see how that applies to a 3 variable question. All right, let's see what the 3 variables are. Marina started with a total of $24,500 to invest. If you've been watching the news, the stock market has taken a huge hit in the last month. So it actually probably is a pretty good time if you've got extra money lying around to invest. I don't personally, but if I did, I'd be investing now. $24,500 to invest, and she ended up earning $1,300 in interest. She earned this interest by putting her money into accounts that yielded 4%, 5%, and 6% annually. If the money in her first account was 4 times the money in the second account, how much did she initially place in each account? All right, we have 3 different accounts going here, and so that's why this is a 3 variable problem. So I'm going to identify X as my first account, Y will be my second account, and Z will be my third account. And we are going to set up a system for this particular question. Started with a total. All right, that's an important. So her first, second, and third accounts all combined had that as a total. So that's just straight out X plus Y plus Z equaled the $24,500 she had to invest. Then she earned interest. Now this $1,300 interest is going to match up with the interest numbers that are listed next. So we set that up this way. 4% interest is 0.04x. 5.5% interest is 0.055y. And 6% interest is 0.06z. And the total interest is $1,300. Lastly, we are told that the money in her first account is 4 times the money in the second account. The money in the first account was X, and it's 4 times the amount of money in the second account, so X is 4Y. Now, this is not set up well for a matrix, because a matrix needs to have all the variables on the same side. So this particular, although it's correct, I need to move things to have it be all set up correctly on the same side. So I'm going to subtract 4y to both sides so that it looks a little different. When I subtract 4y from both sides, this is what I'll end up with. I'll end up with x minus 4y. And then I'm not going to go equals right away. I'm going to have 0 z's, and it's equal to 0. Okay? So it's important that when you are working with matrices that you do have, even if you have just a 0 in front of it, that all of the letters, all the variables are represented in every line. Okay? All right, now we're ready to set up our matrices, and I'm going to add 1s in front of the variables that don't currently have a coefficient, and I'm going to set up my coefficient matrix. So 1, 1, 1 is the top line, 0.04, 0.055, and 0.06, and then 1, -4, and 0. This again is a square matrix. This is a 3 by 3 matrix altogether, and this is going to be matrix A in my calculator. The variables for this one are x, y, and z. Or maybe you used F for first, S for second, and T for third. That would have been fine. And then my final matrix is the 24,500, the 1,300, and 0. I do need the placeholder of 0, and this is going to be my B matrix. So once again, I need to set up my matrices in my calculator so that I can solve this. Alright, I've now set up my matrix A. I've changed the dimensions to be a 3 by 3, and then I've put in 1, 1, 1, 0.04, 0.055, and 0.06, and then 1, -1, and 0 I've included. Now I'm going to edit my matrix B, so I'll go over to Edit, go down to matrix B, and that will be a 3 by 1 this time. So I put in the initial amount of money she had to invest, the interest, and the 0 value. Now I'm ready to solve it the same way with the inverse matrices. So once again, we are going to multiply, this is my x, y, z matrix, multiply both sides by the A inverse matrix, and it has to be, I can't stress that enough, it has to be in the front of the multiplication. All right, so A inverse on both sides, that will cancel this out, and then we will end up with values for x, y, and z, which stood for our first, our second, and our third accounts. All right, I did notice that I put in 24,700, so I fixed it. It's 24,500 in case you were worried about that. All right, now we're going to use quit out of here, and I'm going to do the same thing. I'll do my matrix, and I'll call up matrix A, which is a 3 by 3 inverse times matrix B. And then I get a perfect distribution of how her money was divided. $8,000 in the first account, $2,000 in the second account, and $14,500 in the final account. Okay, so $8,000 was our result for the first account, $2,000 for the second account, and the final account, $14,500 was the value of how she divided up her money. So that was much quicker than doing elimination 3 times. Now let's look at a problem that's got 4 variables in it. And again, if we were doing substitution or elimination on this one, we'd have to do it 6 times. First time, once, twice, and 3 times. You add those up. 1 plus 2 plus 3, that's 6 times. Imagine if we had 5 variables, we would have to do once, twice, 3 times, then 4 times. So that would be 10 times of elimination. So the matrix method is definitely much better for these problems that have lots of variables. All right, Daniel bought a pound of jelly beans, 2 pounds of chocolate, and a week later he bought 4 pounds of caramel and 1 pound of jelly beans. Then he bought 3 pounds of licorice, a pound of jelly beans, and a pound of caramels, and then 2 pounds of licorice, a pound of chocolate. How much will he have to pay for those 4 kinds of candy if he buys 1 of each? All right, we've identified our variables, 4 kinds of candy. So you can do A, B, C, D, however you want to do that. I'm going to say A are the jelly beans, B are the chocolates, C for caramel, and D for the licorice. Now when we set up our system here, we're going to go for the totals. So a pound of jelly beans, that's 1A, 2 pounds of chocolate, that's 2B. But remember, all of the other variables need to be accounted. So that means 0 caramels and 0 licorice for a total of 250. A week later, he bought 4 pounds of caramels, so that's 4C, and 1 pound of jelly beans, that's 1A, but he didn't buy anything else. So that would be 0B and 0D. The total of that was $5.50. The next week, 3 pounds of licorice. So this is my first chance at doing licorice. A pound of jelly beans. He really likes jelly beans. And 1 pound of caramels, but no chocolate. That equaled $2.50 again. And then yesterday, 2 pounds of licorice, 1 pound of chocolate, and nothing else. So no caramels and no jelly beans, for a total of $1.50. Okay, now our system is set up. Now this is going to be a 4x4 system, and so I just have to make sure I keep everything in order. The coefficients for each of the variables. And then my variable matrix would be A, B, C, D. And then 250, 550, 250 again, and 150. And we are going to put the 4x4 matrix into matrix A, and then we will still have our variable matrix. And we'll put the 4x1 matrix into matrix B, and we'll do that in our calculator. Okay, now I'm ready to edit my matrices, and I've now changed it to a 4x4, and I've put in all the appropriate values. I have also edited my matrix B and made it a 4.1 by 1, so 2.5 or 250, 550, 250, and $1.50. And now I'll be using matrix multiplication. So I would like to use matrix A, but it's inverse, multiplied by matrix B. So we get 0.5, 1, 1.25, and 0.25. So let's go back and match those up and see what that means. All right, so we multiplied by matrix inverse on both sides, and I did it in the front here. You can even try and do it backwards and you should get error, so that helps eliminate any foolish mistakes, because the calculator knows you're not supposed to do it that way. Okay, we got 0.5. We also got 1. We got 1.25, and we got 0.25. Now what does this mean? Okay, these are not pounds. These are prices. This is 50 cents. Okay, 50 cents per pound of jelly bean. This is $1 per pound of chocolate. This is $1.25 per pound of caramel. And then 25 cents per pound of licorice. Okay, so again, these are not pounds. These are prices. Now we're going to use these prices to answer the question. The question is, how much will he have to pay on his next trip? Okay, so let's look at the actual question. How much will he have to pay on his next trip to the candy store if he bought 1 pound of each of the 4 kinds of candy? So we need to find our new and final total. And so we would have 1 pound of the jelly beans plus 1 pound of chocolate plus 1 pound of caramel plus 1 pound of the licorice. So that would be 50 cents plus $1.20, plus $1 plus $1.25 for the caramels plus 25 cents. And so a pound of everything adds up to be perfectly $2 total bill for a pound of all kinds of candy.